Hi everyone, hope you're doing well today. I wanted to go over a little bit about series circuits with you and review the pre-lab and post-lab form in relation to the virtual lab that you had to do. So you'll notice here on the screen that we've got a circuit set up using the numbers from the virtual lab. We have 20 volts for our battery and 10 ohms, that's what that omega symbol means, for each of our lamps. That means they have a little bit of resistance to them. Meaning that it's a little bit harder for the current to pass through. You'll also notice that there are a bunch of little blue dots with negative signs in them. Those are electrons in the wires, and so the electrons are going to move, and that's what's causing there to be current in the circuit. The faster those electrons move, the faster the current is going to be. Now, right now, nothing is flowing. That's because my switch is not closed. If I close the switch, you're going to notice, as I asked you for question 1, that both lamps will light up at the exact same time, and that's what we have going on. The switch is providing no resistance, electrons flow right through it, and both of the lamps, even though it looks like the electrons might hit one of them first, they will light up at the same exact time. The reason being, there are already electrons in the wires, so the second I close the switch, those electrons are already starting to flow. I'm going to open my switch for a second. And the next thing that they're going to ask us to find is the voltage across each of the lamps. So to do that, I'm going to find the voltmeter, and I'll drag that over to the side. And as you might have seen from one of the Khan Academy videos, to determine the voltage of something, you're going to have to put these probes on either side of the thing that you're trying to measure the voltage of. So let me do that. I'm going to close the switch, and I'm going to put one probe of the voltmeter on one side of the lamp, the other probe on the other side, and notice it reads 10 volts. I'm going to now do that on the other light bulb, so let me disconnect it here. Now, if you had accidentally gotten a negative reading for the voltage, all you need to do is switch the location of the black and the red probes. So for example, if I had put the red probe here, the black probe here, it would be negative 10. So all I have to do is switch the location if I had gotten a negative number. And so in this case, notice I'm getting positive 10 again. That means that the first lamp had 10 volts across it. The second lamp also had 10 volts across it. In total, there were 10 volts each, 20 volts altogether, which makes sense because there were 20 volts from the battery. So these two lamps had to share the voltage from the battery because they came one after another. That's why we call it a series circuit, one after another. I'll disconnect the voltmeter in this case. And now we're also asked to find the current through each of the lamps. I'm going to do that using an ammeter. Current is measured in amps. That's why the ammeter is used. I'm going to pull that aside. And this is just one that you hover over. In a real circuit, you would have to disconnect the circuit and then insert the ammeter. But I'm just going to hover it over the filament, the middle part of this lamp, and I'll notice it's 1 amp. And if I reconnect the voltmeter, remember this was 10 volts. That should make sense to those of you that were following Ohm's law. Ohm's law says V equals I times R, voltage equals current times resistance. So if I rearrange the formula, voltage divided by resistance equals current. 10 volts divided by 10 ohms equals 1 amp of current. If I move my ammeter to the other lamp, notice it's the same exact thing. There is only one path for current to flow, so it makes sense that current is going to be the same everywhere. In fact, Ohm's law still holds true. Notice how I move this over. 10 volts divided by 10 ohms gives me 1 amp. Let me move my voltmeter and my ammeter off the screen now. Actually, I did that a little prematurely because we do want to measure the current through the switch. You will notice it is also 1 amp, and that's because the current is the same everywhere. So even though the current was 1 amp here and 1 amp here, even though there's no resistance to the switch, it's just one complete cycle for the series circuit. The current is going to be 1 amp there. Now, what happens if I disconnect one of the lamps? If I disconnect lamp 2, notice lamp 1 stops. That makes sense. They were all in a row, so if one of them gets turned off, the whole circuit shuts down. Same thing happens if I were to disconnect lamp 1, lamp 2 shuts off. I need a complete circuit to get a continuous flow of electrons. If I reconnect it, now I have my circuit again. Hopefully this helps you out, and take a look at your answers and see how they compare.